So let me just restart this. So welcome back. We are GDD403 in the winter 2023 semester at Canadore, and it's week 4 equivalent, not week 2, part 2 of our broadcast and recording. And the last recording that we made and the last thing we talked about was about arrays and lists. And now we're going to be doing the first part of our in-class exercise for today. All right. So let's do that. So like I said, I have, if you look at the course shell, I asked you guys to download under our course shell. When I say course shell, I mean things on iLearn. I asked you to download this ICE2 starter. All right. So did anyone have any issues with this thing? Did you guys all successfully download it and work it? Yes. How about this? X if you couldn't make it work, check mark if you're good. Thank you, Justin. How about the rest of you guys, Scott, Mark, and Daniel? Okay, and Daniel 410 says okay. How about Scott? Are you good? Just want to make sure everyone's good. Thanks, Mark. Waiting on Unity install. Okay, so you may have to watch this again a little later. Scott, I just want to make sure that we continue as we're going. Thank you for that feedback. I'm so sorry about that. Okay, so let's continue. So we have a project that I mentioned before, and this is, we have a little camera here that kind of takes a look at this gaming table. We're going to use this for our examples. Like I mentioned before, we have a set of cards that we're going to use for some examples. We have a club, example. We have all the clubs, and they're listed just like any playing cards you might see. Again, one thing to notice, to note, and I want to say this in terms of as a disclaimer, this is not encouraging you to gamble in any way or anything like that. And I'm saying that because I don't want this to be misconstrued as a gambling, simulation. It's not. All right. So it's literally just, we're going to use these things because cards have a few properties that we're going to set up that we're going to talk about. One of them is the rank, which is the name of the card, the ace of clubs, as a good example, right? The suit, right, is the other thing, clubs, all right? And the value. What is the value of an ace? Sometimes it's a 1, and depending on the game, sometimes it's a 14. It really depends, all right, how we're going to use this thing. So cards have different values, all right, different kinds of things. And we also have a prefab that I want to use here, which is the card prefab that we're going to include in our card class. What I want to do today is I want to start developing the card class with you from scratch, right? This is going to be for your assignment 1. I'm going to help you build it with your in-class exercise 1, in-class exercise 2. We're going to put it up on GitHub and all those things. And I want to do this because it will set you up nicely for the way I want you to code. What I'm hoping is for those people whose coding is not a first practice, if you will, maybe you're more of an artist or a designer of some kind. That's okay. I'm going to try again, fill in the blanks in terms of everything we're doing here, Unity, Visual Studio, the whole thing, okay? So please, if I'm going too slow for some of you because you have a software background, forgive me. And I'm asking that, I want to make sure that everyone's on the same page, and that's why I'm doing it this way. Not because I want to be slow or whatever. In fact, most of the times I'm not slow. So let's go into scripts here. So this is the first thing I want to do. So under scripts, so I kind of did a bit of a tour of the little starter that I gave you. And in scripts is where I want to put in my first script. But I need to attach it by default to some kind of object in the scene. And we don't really have an object to attach it to. So I'm going to make a brand new object here in the scene. I'm just going to right click in Unity here in the hierarchy. This is what I'm doing. And I'm going to create an empty object. We're going to rename this empty object and we're going to call it game controller. This is a very common practice. In fact, we can actually add a tag that is the game controller itself. If you really want to identify the game controller, we can tag it as well. One thing is whenever I add empty objects into the scene, I always have a practice of resetting the object here. And you can do that again by going into the component for the transform and resetting it. It will reset it to 0, 0, 0. Also, the table right now is set at 0, 0, 0. The directional light is set at a certain spot to give us some, basic direction. It doesn't really matter. This is going to give us the same lighting through the entire scene, right? And the main camera has been set up so it's going to look at the game board. Again, from a navigation perspective, you can see what it's doing. It's kind of looking down at the game board like this. We don't have a room in the background or anything else like that. It's literally floating in space, okay, which is okay for us. Whenever we want to kind of snap to the camera, we can press F to frame select, and we can kind of look at what the camera is looking at. And what we're seeing here is the frustum of the camera with the near plane and the far plane. Okay, frustum means like this cut off pyramid, where the top of the pyramid is kind of a rectangle, and the back of the pyramid is a rectangle, right? But it looks like a pyramid shape. All right. So I want to kind of zoom in here. One thing that we also get in the editor in Unity, because I'm looking at the editor here, is that we get sometimes these 3D gizmos are pretty big. So at the top here, what I always like to do is the 3D icon, I want to make it smaller. So it's just not going to be in our way, right? That's the only thing I don't want it to be. So we can kind of look at the scene as an example, and maybe we want to see the camera, but we don't want it to be like in our face all the time when we're setting things up, okay? From a game perspective, one thing that you can see is the game is in free aspect mode. And I want to change this for you guys when we build this game, because we're going to build it for our in-class exercise and for everything else. So instead of being free aspect, I want to change this to my own resolution that I'm going to be using. And I recommend a resolution of 1024 by 768 for today and for your assignment. So the way this is going to work is you can go down to where it says, so again, there's two tabs. There's a scene tab and the game tab. The scene tab is where we do all our work, our editor. In the Unity editor, the game tab is where we have, we can see the game and how it's going to look, a preview of the game itself. Not a real-time view like Unreal gives us, but on something that looks like this we can play, of course, and all that kind of stuff. Here, what I want to do is instead of looking at free aspect, I want to click the plus here and then choose a name. I'm choosing WebGL because one of the things that I want you guys to do for your in-class exercise today and for your assignment one is export to WebGL. All right. And the reason for this is because although it takes long, is that means literally I can play your game on the internet, right? Which is something that we're going to be doing. One of the outputs of today's lesson is how do I make a game and export it to WebGL and then click on it and run it anywhere in the world. Okay. How do I do that? And you can do that nicely with Unity. This is what Unity has that maybe Unreal doesn't do so easily. Okay. And the question before we go on is, have you guys ever done a WebGL build? Because if you haven't done a WebGL build, you need to set it up. Remember, I asked you guys when you were first installing Unity, and this is for you, Scott, too. You need to also include that component, WebGL. And if you don't, you can always add it later. Okay. So please make sure you do that. So have you guys done a WebGL build before? But Justin says you've done it in your programming program. How about the rest? Have you guys done a WebGL build? Scott says no. This is going to be new then for some of you. And there's a couple of targets for a WebGL build. One of them could be GitHub. Another one could be some other place. We're going to use GitHub pages, all right, to make our WebGL build, which means for this lab, I'm going to have a special folder that we're going to have that we're going to use for our WebGL build, and we're going to call it docs, the docs folder, right? We're going to talk about that later on, okay? Just bear with me as we go through this, and we'll discuss how we're going to make it work. So you can still have one repo, but where there's going to be a separate folder that we're going to use for our build. So here, what I want to do is I want to make a brand new aspect for our game. And we're going to say that the label we're going to use, we're going to call it WebGL. So all you do is put in WebGL in here like this. Okay, I already did this. You can see that I've already done it here. And I got that by going to free aspect in the game tab, and then change the ratio for width to 1024 and for height to 768. Okay, that's what I want you guys to set up. So that is what you would do, if you press OK here, then you'll have an entry that looks like this. I already have that, so I'm not going to press OK. But if you press OK, you'll have that entry. And then all you have to do is click onto it, and you'll see that this is what your game will look like in WebGL. It'll look just like this. Notice that it's not quite centered, and we're going to fix that. How to fix that? Well, this is what the camera sees, right? And you can see that it's cut off on the right-hand side here, and that's okay. So I'm going to go back to my scene, and I'm going to go kind of look. Here is a preview of what the camera sees, and I want to kind of frame my scene, and you can do that by kind of moving the object around a little bit. I want to frame my scene, so whatever I'm looking at here in editor is what the camera is going to look like here. So notice the camera's way over here now. I can right click on the camera and then go align with view. If I do that, you can see that now I can see exactly, my camera is now realigned so that at the bottom here, there's a preview. You can see I see the legs of the table. I don't want to see the legs of the table. I want to bring this view down here so that the bottom of the table right here is at the, kind of where I'm looking. If I want to re-angle myself so I see more of the table than the legs, I can do that because I don't really care about the legs of the table. I just want to see the table in a perspective view, right? So that's what I want to do. So, and then you can kind of rotate this just to make it as clear as possible. So something that looks like this. Notice that it's cut off on this side. If it's cut off on this side here in the view, it'll be cut off in WebGL. So I want to move it over so it's not cut off. And that might mean zooming out a little bit. And you can move this kind of away, but you may want to zoom out a little bit until you can see whatever your window looks like here is what the camera is going to see. So this is kind of where I want to go with this. And then I'm going to right click again on main camera and then go move to view. And then you can see that, let's try that again. I meant align with view, which is going to be exactly what the camera is going to see. And then when I go back to my game, you can see that that is exactly what the camera sees, okay, the game. Sometimes we want to do things from a top-down view, but then that would be like 2D. And I want to try and make this game like 3D, and that's why we're doing it the way it is, okay? So that's kind of how it's looking like. I want to file, save now, and that'll save the scene the way we've got it. It's just, if you wanted to match up my stuff with yours, let's take a look at the main camera and put in some other values here that might make sense. So something like 0.03 might be okay for the X coordinate of the main camera. If you wanted to do exactly what I have, is what I'm saying. And here, 12.8 is probably good enough for the camera, right? And I'm just rounding these numbers a little bit. And then 3.7 probably is a good number for the Z coordinate, okay? From a rotation perspective, probably 61 might be okay. And then here it's 180 clearly is what we want for the camera. Okay, so that is the camera. So these are the values that I want. So if you want to match my values with your values, these are them. Okay. One thing to note is you can always kind of copy the values, right? 0, yes, you can do whatever makes sense for you, Justin. I just want to make sure that if you wanted to kind of, go with my values, you could. You can always copy any one of these components here. If I copy position, and if I right click and paste into your chat, you can see that it gives me a vector 3 that looks kind of like that. So that kind of is the exact position of the camera if you really want to be straightforward. You can always copy paste and it'll convert the position vector into a string, which is what I just did. Okay, so that's kind of an important thing. Remember that all game objects in Unity have a transform component. That is part of the Unity framework, all right, the Unity game engine. All right, great. So we've done that. We've saved the game and we have our view, and we're going to talk about building this later on. What I want to do now is I want to start building up the card class, okay? And I have my game controller. We're going to kind of generate a list of cards, which we're going to call, again, a deck of cards. And this is, because we're doing it in our in-class exercise, it's going to be one of the things that's going to be part of your assignment 1 that's going to be required, okay? So let's do this. And we're not going to complete all the stuff that I want you guys to do with your deck class. There's going to be some things that are not going to be included, okay? And we may change stuff up, not from this week to next week, okay? So again, let's in the scripts folder now. I'm clicked on the scripts folder. I'm going to right click here and I'm going to make a brand new C# script. And this is our first script together. We're going to call this the card script. So I'm just going to call it card like this. And the card script is going to be a new C# class. All right. And last week, we also talked about the difference between structs and classes a little bit. So again, structs in C++ are very basic, kind of objects, but their structs and classes in C++ are the exact same. C++ classes are private by default and structs are public by default. C#, it's not the same. In C#, structs are value types. They cannot be inherited from. And in C# classes are reference types and they can be inherited from. Okay, so they're quite different. That's why I'm making this a class. Okay, not that I'm going to inherit from it, but I'm going to make other things from it. I'm going to use something called composition to do stuff. So let's go into the class itself, the card class, and then we can see what we're going to use. So I'm going to double click here on the actual C# script, which should bring up your default. Editor. Mine here is Visual Studio. Okay. And by default, we know that whenever we do a C# script in Unity, that the default things we get is that class inherits from mono behavior. Card inherits from mono behavior. So what I want to do is I want to associate the card class with the game object. So each game object is going to have the card class connected to it. So if I have an ace of clubs, then the card class is going to be associated with it, and the card class will identify what that game object is. Okay, so let's do a couple things here. I'm going to go back to Unity. We made a card class that's just a stub right now. It's really empty, and I want to grab some of my resources here. I want to go into prefabs, so resources folder, prefabs, and I want to go into the cards subfolder. So this is the folder structure that I've given you in our starter. And Rin, thank you for joining. I've asked the class to download the starter, which is GDD403, and then the ICE2 starter. That's what we're going to be starting with this week. Okay, so please download and install that. Okay. All right, so very good. So now that we've got our access to all of our stuff, let's start with some cards. Now, remember, this is a great thing. I can associate the same script with all of these things, but let's just pull up one card. We'll actually use spades because the ace of spades is special for some people. Ace of spades. We'll pull this in here, and there's the ace of spades, but you can't see it because it's like below the deck of the table. Let's bring this up by using this, kind of our control handle here. There's our ace of spades. This is again in 3D. We're just using this, and we're just going to put it so it hovers above the table just like this. Okay, that's the first thing. I want to attach the card superclass to the ace of spades, and this way what we can do is we can start doing this once we do it for one card, we can do it for all cards. Okay, this is the first thing we're going to do. No problem. No problem, Rin. So here's our ace of spades. I want to go to the spade A prefab, okay? And then what I want to do is I want to attach, so I'm just going to minify these things or collapse them, right? We don't need these right now. Also notice that all of my prefabs have, like I said earlier, a rigid body. So it means that they'll react with physics. They have continuous collision detection, which means they won't fall through the table or something weird like that. And they have a box collider that's associated with each of them because they're 3D. They're kind of like a small box in some ways, right? Like a really thin box. We could make it slightly bigger, but then when we stack the cards, if we're ever going to make an actual deck of cards to visually appear in the game, which we may not, that the cards could literally stack on top of each other, which is okay. And they're not, you can shift them around and all that kind of stuff. If we were going to do a VR game, right, then these items that I've created here are big, massive, in fact, and we'd have to kind of scale them to room size. All right, but for now, it's just easier for us to see it in this way, and that's why I've kind of I've scaled the table, which is, if you look at the table scale, it is 1, 1, 1, but inside the table itself, the table mesh for those people who've done things with Blender, and all of you have, is 10 times the regular scale. Okay, that's one thing to notice. And same thing with the spade. The spade is 10 times, as an example, the size. Now, this prefab spade A, if I double click onto it, right, it'll kind of frame select the card. That's one thing to do. But I can also go into prefab mode and see what the card looks like, right? So this is the spade A prefab itself. So I'm actually modifying the prefab. Back to this mode, though, we don't need to do that right now. What I want to do is I want to just collapse these two things, and I want to go into my scripts, and I want to drag and drop my card script to the button where it says Add Component of the Spade A, the Ace of Spades card. That's what I want to do. So there's that card script that's attached to my Ace of Spades. Okay. So the card script doesn't do much right now, but it needs to identify a couple things, right? The suit, the rank, the value, is the card flipped or not, right? Which is kind of important. And we're going to make it so that it does all that stuff. It's going to flip, like turn over, and all that kind of stuff. We're going to create those methods together today. And this is part of our in-class exercise, okay? And one of the ways we can probably do such a thing is, if I want to flip all the cards over, we might make a little control that when we press onto it, just to test the flipping function, we'll just flip it over, right, with some kind of animation, okay? So this is the card, and let's double click again on the card to take us back to this. So we know that each card script is attached to each card object, game object, okay? That's what it is. And so therefore, card is going to be a game object. That's what it's going to be typed. It's going to be a type of, a game object that we're going to set up. So card needs to be part of mono behavior, because mono behavior indicates that the script can be attached to a game object in Unity. Okay, that's the kind of thing it is. And you can see that just to kind of go over this, public class card inherits from, that's what the colon stands for, of type mono behavior, right? And mono behavior is the superclass of all game objects in Unity. And one thing we can do in C#, which is interesting, is in here, we can actually add in, if I go to add, and I can add a new item here inside Visual Studio, it'll pull up a little dialog box. That's what this is.
Sorry, how do you open up that little side tab? Because it's not there on my screen.
Maybe it's like this, I mean. So on the right, there should be Solution Explorer here. And if you don't see Solution Explorer here, you can always go to View on the left. And then on the left, you'll see a lot of common windows. One of them is Solution Explorer, which is Control W and then S.
I got there. Yeah, there it is.
Okay, and then you can pin it on the top right. You can pin it on, so you can kind of pin it, right? And if you pin it, it's always going to be there if you want to, right?
All right. Yeah, thank you.
No problem. So that is your Solution Explorer. So what I wanted to do was, again, you might have seen something that looks like, like this. This is what it looked like. And then if you expand these little nodes, if you go to Assets and then Scripts, and if I right click onto Scripts like this, it should pull up another little menu where you can do Add, and then you can select New Item, Add New Item. And then when we go to New Item, on the bottom, these are a collection of things, templates that we can use in C#, right? That we can use. This is part of Visual Studio. And there's quite a few templates that we have here as well, right? So everything from TypeScript to whatever, right? Lots of little things here that we have here. What I want to pull in is the class diagram. See this class diagram? So class diagram. And let's just call this the, ICE2 class diagram. I'm just going to use no spaces here like this. ICE2 class diagram. And it's going to have an extension of CD. Okay. I want to click add here, which is going to add the class diagram to the scripts folder. Okay.
Sorry.
What this also.
Sorry to interrupt again. In the Solution Explorer, there's no drop-down menu. There's just that. Yeah, I don't see that. Like,
you don't see anything in Solution Explorer? What do you see?
I see one thing that says just solution.
This part up here?
Yeah, but it just says solution one instead of GDD403.
Okay. It could be because when you opened up your in-class exercise, it didn't show you this, right? So I'm not sure why that is. So when you went to Unity, did you just double click? Did you double click on this?
Yes, it did.
So when you double click and it didn't show, it shows this, but it doesn't show this.
Yeah.
How about everyone else? Is everyone else seeing the same thing? Can you not see this part? If you can't, it's okay. I was just going to demonstrate some stuff anyway, right?
Okay.
It's not critical. Okay.
Okay, that's
But I want to, I'm gonna share this file. Okay, yeah, switch to Visual Studio, please, and then you'll have the same detail. All right, so here here I've got a class diagram, and what a class diagram is, it actually gets we can actually look at it in Unity as well. Class diagram, it doesn't do anything here, but one thing that we can do with a class diagram, if I double click on this, if you have access to this, and by the way, here's another reason why you may not have access, is because I'm using the enterprise version of Visual Studio 2022, and you might be using the community version of Visual Studio 2022, and it may not have that thing, right? That option that you can see details. Typically, you can. So here, what we can see is I have something called the class designer in here. And what I can do is I can take my card class from the right-hand side and drag and drop it into my card design and my class designer. And you can see a visual representation of my card class here, right? Which is kind of very useful. So the one thing that you can do with it at the top, you have some, kind of objects here that you can look at. I can kind of expand everything so that you can see all this. And it says inherits from class mono behavior. And what you can do is you can say show base class. Now, I am recording this just in case you wanted to try this later on and you can't do it right now. So here's show base class. And you can see that it has this little line because we're making a UML diagram. And this diagram basically shows us the superclass of card. And then what I can do is I can expand it so you can see all of the methods, right, that are inherited from our superclass. This is the stuff that comes with every game object that you make in Unity, right? And remember I talked about how inheritance is positive, but here's something that's negative. The inheritance hierarchy, whenever we have inheritance in general, when I move from a superclass to a derived class, or sometimes we call them different things, by the way. Sometimes we call them parent class and child class, a base class and a derived class, and so on. Lots of stuff, right? So here, this is the base class or the superclass mono behavior of type card. Card is this new class we're making. And because card inherits from mono behavior, it includes all of this stuff. Okay, all of this stuff. And includes stuff that maybe you don't know about, like, for example, invoke, right? Or cancel invoke, or a bunch of other stuff here. Okay, that's what it does. We can go further than this. I can right click and I can show base class. And you can see this base class inherits from something called component. So component is the superclass of mono behavior, right? That's what it does. And that inherits from behavior. Mono behavior inherits from behavior, and then behavior inherits from component. And here's my component superclass, okay? And component further inherits from object, show base class. Here's object, right? And you can see what object does for us too. So this is the inheritance hierarchy for what we're doing right now. Why am I showing you this? Because, my friends, when we start inheriting from one class to the other class, we always must think about that our child classes are much fatter than our parent classes. Maybe not the same in real life, where the parent, like I said, maybe another time is fatter a lot of times than the children, like dad bod, whatever, right? But not the same in programming at all. Programming, the parent classes are super fat, right? Here, you can see that that's true, right? Each of these classes are fat already. And then the child classes are just like massive, right? And the reason why is because we want to inherit all of this stuff into our card superclass. So we can see some things that we can always do. Things like animation, components are animation component, audio component, a camera component, colliders, game objects, renderers, rigid bodies, different things. These are all types of components, as an example, that are going to be inherited by the behavior superclass, and that further are going to be inherited from mono behavior, and further are going to be inherited from card. Right? That's how the thing works. Let's just collapse this one, because this is the object class is inherited by everything in C#, right? So let's leave that over here. But it also includes things like all these methods, like get component and send message, and a bunch of other stuff here, component and compare tag, and a bunch of stuff. That's all the stuff that all components have, okay? And then behavior is interesting because it only has, is it enabled or is active and enabled? That's what behavior has, these two little properties that kind of is an in-between between these two things. Interesting. And then finally, mono behavior has a bunch of parallel programming functions, like a start coroutine. Coroutine is like a little function that we can start in parallel, a parallel process compared to something else we're doing. You can also invoke a function, and sometimes that might solve a problem in terms of the order of execution, okay, when we invoke stuff. So that's what this is. All right, so that's mono behavior. And this is kind of the hierarchy of classes, which means that since, if I go back down to here, and I'll kind of show you how this looks now in the hierarchy, it kind of looks like this. So at the very basic, all of our card classes, the card class is going to have all of this lovely extra stuff that you don't know, you may not know everything about, right? And especially the component superclass, okay? The component superclass has a ton of stuff that is included, and there's just so many things that that are part of it, and you know, that's what our card class looks like. So I'm just going to include this in our insane of our project. So if you wanted to look at this, you can, and you're going to see how every class inherit and kind of relates to every other class later on. For now, we're going to leave this thing here, and I'm just going to save this and close it up. All right, this is kind of a little diagram. That's all it's going to be. What does that look like in Unity? Well, as you can see, you can't really see the diagram in Unity. It would be nice, but they don't have that functionality. All right, so why did I show you that? Because when I go back to here, start is built into mono behavior, right? All you know, classes that inherit from mono behavior have a start and update and all the other lifecycle functions. And we should talk about this before we continue, because I want you guys to be on the same page. Like I said, if I do look at order of execution and Unity, right? We're going to go to order of execution for event functions in Unity. And this is I'm going to kind of give you this reference, the library reference for Unity. This is from Unity 2021.3. Let's see if I can get you a more recent one. This is that one. Let's try that again. I'm going to just give you that in the chat. And I'm also going to put this up on our course shell, because this is kind of a link that we're talking about during our in-class exercise. So if you wanted to look at that, I'm going to make a new link here. It's the order of execution, and it's important to take a look at this sometimes, because there's some really very, very important information, you know, when we're talking about stuff in Unity, right? So you understand stuff, right? So yeah, so what does this show us? It gives us a diagram, and it shows us how all of our event functions, or lifecycle functions, as I like to call them, are yes, yeah, exactly, early update and so on. So if you take a look at that, you can see that awake, here's awake, and then you have on enable, reset, start. So this is where the start function comes into play. Here's your fixed update, which is for physics. Notice that this is in the physics box. And what it does is fixed update is, you know, kind of a deterministic update that basically beats the drum of the frame rate every frame. That's what it does. So every frame, it's a very deterministic thing. Whereas regular update, what it does is it tries to update as fast as possible, tries to execute as fast as possible for your system. Okay, so that's kind of something that it does. So then we have a bunch of other stuff, a state machine, a process graph, blah, 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 animations, on trigger and on collision type events that are built into physics. If I want to do some kind of like collision or overlap, something like that. And then we get into update. And you can see here we have update, and this is game logic parts, right? Where we have update and late update is right here. But notice that, again, just like you said, there's no early update anymore, right? And sometimes that messes things up, early update, late update. But late update is neat because what we can do is, if we want something to trigger after update, we want to update something and then we want to do something else down here, we can do it. I wish there was, honestly, a late fixed update. That'd be good too, right? But they don't have that. Because sometimes we want to trigger things in a particular order. The reason why this is the way it is because all things are going to happen in this particular order of execution in Unity, and it's good to know that this is happening. So a couple of things, that also happen is on destroy, which is you release memory, and instantiate, which happens when we enable or on create, which happens way up here. Okay, so that's kind of the way things are working. And I wanted to show you this when we have an object in the hierarchy in Unity. If I go back to Unity, and if I look here in the hierarchy, anything that's in the hierarchy, any of these objects are instantiated at runtime, which means that their life is breathed into them at runtime, and we're going to see these things. Okay, so going back to our code then. Why do I mention this? Because start and update are two event functions that are always going to be part of every script in Unity. And one thing to note is we cannot leave these scripts, these functions empty ever in any of our scripts, because what's going to happen is the way Unity works is it goes through every script that we write that has a start and executes all those starts all at the same time as much as possible, because that's in the start. In order of execution, all the start methods are run all at the same time. And then it goes to all of our update methods, in this case, way below, right? And if you have an empty update method, it doesn't matter. It's going to check that script anyway. And this is going to happen every frame, right? So startup would be really affected if we had hundreds of objects that had empty start functions. Okay, it's going to be really affect performance in terms of startup. We don't want to have any empty one of these things. So if we don't need them, the logic is remove them. Okay. In our card superclass here, right? We don't need a constructor function because the constructor function is been abstracted away from us in our class. Remember that we're using scripting, C# scripting here, not a classic C# kind of environment, right? Which means that when we write a constructor function, typically when I write a program, and we're going to do that for the deck superclass, right? Typically when I run a program, these are the things that I would run or write. I would run or write a constructor function, and you don't have to type this. I'm just telling you my thinking, right? Some kind of constructor. I might have some public properties, right? Right. I might, before the constructor, just in order of declaration, I might have some private instance members, sometimes called fields or data members, right? That's what I might have. So private instance members, constructor, and you might have more than one constructor. So constructors is what we want to say here. We have the default constructor, we have some parameterized constructors and some stuff like that. That's what I would have. And then after all of this, right, then we would have some kind of public properties. We might have some public methods, right? So functions that we want to see outside of the class. We want to expose these functions outside of the class. And we might have some private methods. So that's within the class itself. And we might even have some static methods, both public and static, public and private, static methods. So these are all things that can be part of any class that I write, okay? But we don't need some of this stuff because Unity takes care of some of this for us. So one of the things that you're going to notice in your assignment when you read it, and I'm this close to finishing it up, I just want to make sure that all the piece parts are ready for you and that it's super clear at what you have to do, right? With some diagrams maybe too. You're going to have all these, you may not have to do all this stuff because it's included for you. However, we do need some public properties, and there's some things we can do in C# that really doesn't work well in Unity. So if I was to go to public properties in C#, normally what you'd have is, let's go back to this. We might have private instance members, and you might declare something like a private. Let's try this. This is for you to try a private, and you want to think about the thing that it's going to create. We want, remember, our rank, right? So our card rank, and the rank name is what we want. So let's call this, and usually to declare the type, it would be a string. So let's say private string, and then the name of the identifier would be something like, and I might use for private members in C++, M underscore, where M stands for member variable, underscore stands for private. This is just a coding convention, right? You might see. So M is member variable, underscore is private, and then the name of the identifier, the variable, which is something like, rank name, so something like rank name. That's what you might see, okay? And that would be in C++. Here in C#, we can certainly do this as well. A lot of times you might see just the underscore. So you might see something like this, where you have an underscore, and in your mind, whenever you see underscore, you should think private. That's what it means, okay? And that's why we use these kind of things. So this is a private, kind of member variable. And let's talk about the other things. We might do something like a private, so the other thing is a string, which is the suit name, suit, let's say. And we might have a private, integer that is the value, okay? So those are the things that we might have, those three things. And maybe the other thing I might want is flipped or not? Is it, if it's flipped over, is it's on the, can I see it? Is face up? Is it face up or is it face down, the card? So maybe we'll do that. So we'll say a private Boolean, right? Which we can say is face up. Okay. So those are kind of, very common ways of situating things. Now look, it's telling me there's some stuff that it doesn't like. So this is resharper now coming back. If I click on any one of these little underlines and I go over to my little hammer here, it's going to say, it talks about I can change it to internal or protected or private protected. I can encapsulate the field. It can be null. I can mark it as not null. I can do all kinds of stuff. But that's all this does. It just kind of says, maybe you want to make the field read only. Maybe a private member card is unused. That's also that saying. These are private members, right? And but for now, let's leave them like this. And then when we make public properties, what we might do is do something like this. We might say something like prop. This is the shortcut in Visual Studio. And if I press tab, then what it'll do is it'll start off. Let me try that again. So we start off with the prop keyword, prop, and you can see that the IntelliSense, this is regular IntelliSense, it comes up with this. And if I pull up this, right, just this alone, then it just does this, almost like your property in one line. The other way to do it is if I do prop and it says G, right, then it'll do a private setter and a getter. Getter would be this would be a read-only type property, right? We can also do, if I do prop and I want the type would be a string, right? So that's the name. And then the name would be what we want to call it. So for example, it should be related to what we're going to kind of expose here. Let's say we would call it rank name, right? And then what you would have is a getter and setter, right? And what you would do with the getter and setter is you can define a get accessor and a set mutator. So this is the get accessor. And this is the set mutator. Yeah, I'm just mentioning these things because the naming conventions that I'm using may not be something that you've heard before, and your other professors may have not mentioned them, or whatever, but I'm talking about it just so that way I can put you all on the same level playing field, like everybody else, all right, that I work with. So I have a get and set, and if I look at getters and setters, if I look at getters and setters in C#, let's take a look. So getters and setters in C#. If I look at that, and if I look at the C# properties, we want to look at Microsoft, the Microsoft, kind of description. You can see that we can do something that looks like this, set, right? And the get property might look also something that looks like this with an fat arrow that we see here. This is kind of like a very simple way of putting things together, where we have our public name, and here's an exact way that we're doing stuff, right? We're kind of setting up things. Then there's a lot of different, kind of ways of putting this together, where I want to say my get accessor and my set mutator. Now they're using the new way of doing it. This is the new Fandangle way of getters and setters, right? And I'm just going to mention that you can also do it long ways, right? Where I go back up here, set, and then get return something, and set something. Let's set it up with curly braces first. So here's the old way of doing it. And this may not be old for you. Okay. So we have our sets, and we have our get. And our get, we're going to return rank name. Okay. And here we're going to set rank name. So m_rank name typically is equal to value, lowercase v, which is a keyword. And this is a way of making a formal parameter. That's what it does. It's a public formal parameter called rank name. And whenever you talk to some people in C++, they might say, we can also use getters and setters in C++. We just call them get and set, whatever, right? I'm mentioning this here because C# has some special features that are good when we're using them here, making a formal class, bad when it's used with Unity. So notice that rank name, although it lights up rank name _ rank name, because we're accessing the private instance member with the public property. That's what this is, right? It's using rank name here, right? And that's why rank name is slightly lighter colored in Visual Studio than the darker colors that we see here for our private member variables that don't have any public property. And this adheres to object-oriented methodologies, which is public properties and private instance members. It's called data hiding. That is what we use when we've learned object-oriented programming. Now, I'm going to go back to some of you guys. I think Justin, you mentioned that this isn't a very programming-heavy program. Did you guys learn in this program? Did you guys learn details about object-oriented programming, like the stuff I'm talking about here? Yes or no? I need to know because then I can switch what I'm talking about.
Not to this level.
Do you want to care about this? Well, that's the other question. Do you care, right?
I want to be able to be employable after this program's done.
Okay, so you want this then?
I would, but I don't know about the others. Justin might want it.
I would.
Yeah.
Or Daniel? You don't care about it?
Daniel said yes.
Oh,
The
he
one.
does, okay.
Hello? Is this working?
Hi. Yeah.
Hi. I was actually thinking of going back and sending you a list of like all the stuff we've worked on so far.
Yeah,
Because
is it a big list?
it's
Right, so-
not going to be a super big list. It's
No, it's do this
gonna be short.
tutorial list.
Okay.
It's
I'm going to
not
give
much.
you guys. Okay, so would you mind? And this, I'm just asking everyone here that you guys are a good representation of the class. Kind of like, do you mind if I go into detail? Does anyone mind? Right? If you mind, I won't do it. right?
I'm
If-
actually enjoying the fact that you're explaining stuff out. You've actually said stuff that we were told not to do. And you
Honest-
said, yeah, like deleting the start and the update because it slows down. We were told to leave those in there because you might need them.
No, ever.
Exactly. So that's what I'm trying to say is like you explaining this, please. Yeah, Justin saying, please go into detail because we weren't given details. We were told
Yeah.
do this, do that, and then we just figured everything out on our own. This program's been very self-taught. So we're all at very different levels depending on what we wanted to do with our assignments.
Okay,
And
so let me,
just to, oh, sorry, go ahead.
oh, no, go ahead, please.
Just to add to what Rin has said, most of our stuff in this has literally been just follow along with the professor, copy what's going on kind of stuff.
Well, okay, so it's good and bad. Good because monkey see, monkey do. It kind of gets your mind, kind of you get some of it as you're doing it when the other person. Bad because then you need to figure out stuff on your own, and debugging is a big one. And I'm gonna just code on the fly, guys. I'm not gonna prepare everything that I'm gonna talk about. You and I are gonna figure things out as we go, like we're doing right now. Okay. And so Daniel, don't worry about that. All right. I want you all to be a better level of programming when you're done with me. Okay. My job, by the way, this is my mandate personally. It has nothing to do with Canador, right? When I'm with you, I want to bring you up to the next level. That's me. Okay. Because that's what I do with every place that I teach. I'm not going to sit there and try and make it soft for you. But some things I'm going to ask you to do are maybe a little bit more challenging, maybe might push you. Some things might be easier. It's okay. But I'm going to try and fill in the gaps. That's what I'm trying to do now because I don't know where you're at. So if I'm going on about stuff, it's because I'm just trying to fill in those gaps that I don't know. Right. So maybe Justin, don't send me that list. And I'm going to assume you guys don't know. Right. And this way it's just better. Right.
I had you at George Brown when I was there
Yeah.
in 2017, and I told everybody, I'm like, he's a great teacher. He's actually going to teach us because Canador compared to George Brown, no offense, Canador is great and all, but what we learned in George Brown in the year and a half I was there was nothing compared to what I've learned here in almost 2 years. So I learned way more there. So that's why I was like, we have a good prof coming in.
Okay, good. I'm glad that you're okay with that. Thank you for that feedback. I'm going to continue then, just to make it so that we're moving on. And I'm saying all this stuff because I want to make sure that you guys are on the same page. So here, let's go back to this. So here we've got this public property and private instance member. This is part of OOP, object-oriented programming. And one of the things that we're doing here when we have these two things, I'm just going to use my annotator. That's going to be part of our, so when the recording comes in, you can see what I'm talking about. So from this part and this part we're doing, right? This is part of what we call information hiding, okay? So information hiding, it covers OOP, right? Because what we're doing is we're only exposing almost like a delegate, like a front man, if you will. That's going to represent the private data member. That's what this public property is. The public property is a representation of the private instance member. And the question I always get from students is, why do we need it? And the reason why we need it is because if I want to make a testable framework, and for example, I want to know when I'm getting a value, I can set it up so that way it sends a message. So I can test the framework out. I can say, well, someone got a value here, and I can do better debugging. I can also do, because each of these things is a method. All of these things, this one and this one, they're both methods. In C++, it would just be called get rank name and set rank name. That's what it would be called in C++, because you don't have getters and setters like this. C# is a beautiful language because what it does is it has this extra stuff. But this is the bad thing. We can't see this stuff in Unity. And that's why I want to tell you about it. And I'm asking you to forgive me because I went through all this, so you know it's there. And we may use it in our classic classes, the ones that we're going to use. We're going to make another one that's going to be interesting, but we cannot use it here in C#. If I go to my spade as an example, see, there's nothing that's exposed here inside the script. We can't see that public property. We can't see these private instance members because it's even this, the way it's created, is not accessible. I wish that Unity would do that. I wish that we would allow that it would somehow expose public properties. That would be awesome. Because then you'd have a full, kind of control of, making a testable framework from the get-go. So scratch that. I'm sorry to say that. These things are either going to be public or they're going to be private. That's how it's going to be. And we don't do the testing the same way in Unity. So here we'd call this rank name and we make this public. All of these, if we want them to be exposed, would be public. You can also use serialized field, but we're not going to do that right now. I'm just going to change these all to public for a second and rename these things to something else. Notice in Unity, you can make it like this, rank name and value. You could do this. And what we will do when you do this kind of thing is when you make them public, what this does is these instance members, these are like public instance members. They're not properties, they're public instance members. And when you make them public, then going back into the inspector, what you're going to see is that they're going to be exposed in the inspector. We're going to be able to see them here, right? See how they're available now? And they're all, they use upper camel case for the name. So if the name is called rank name, Unity hunts for the name of the variable. And if you have something that looks like this with a camel case, it takes the second thing and makes it into its own name, own word, and that's what it exposes here. It's very nice. And we want stuff to be exposed here because it's kind of important for us to do, okay? So that's rank name, suit, value, and is face up or not, okay? And is face up is going to be interesting because we want to make sure that by default it's false. It should be turned over. But that means that our rotation should be facing the table. The normal, which is now pointing up, right? Which is like, this is the natural state. We want the normal to point down the other way, right? So, yes, it would not to get set. It wouldn't do that. I wish it would, Justin, I wish it would. But the answer is no, not with get set. So, and it'd be awesome if we were able to serialize something, but we can't. Let's get back to this though. So if I want to rotate this and I want to rotate it across the Z axis, so let's do that. Let's rotate across the Z axis 180 degrees, right? Oops, 180 degrees. Then we'll see the back of the card. So whenever we see the back of the card, then like this, that is when we consider this face down, right? And the way we consider it face up is when the card had an angle of 0. So this is a way of detecting if the card's facing down or facing up. Why? Because there's only going to be two positions, looking downwards or looking upwards, right? Now, there's some interesting tools for this because if I was to rotate this, my card to 180 degrees, right? The card itself is looking in a different direction, but we have the local rotation that we can pull to see what this looks like. So when we rotate it, when we flip the card, we rotate it or we toggle it to either 180 or 0. Okay, those are those two values, right? So for now, we can say that by default, right now, is face up would be true because, well, it's facing up, right? Okay. So those are things that are important to do. Rank name, suit, value is face up. And we want a method to do exactly that. We want to make it so that we can change is face up to whatever we want. Things that we're not going to need right now is the start and the update function, because for a card, right, in many ways, it's not going to help us. It's just going to give us some properties, right? In many ways, if we could make the card the struct and we could inherit from mono behavior, that'd be awesome. But we can't. So not in the right way. So we're going to get rid of these for now. So no more start and update functions. But what we do want is some kind of flip method. So let's do that. So we'll say a public method that is of type void that is called flip. And what flip will do is it will toggle is face up. So we're going to say, we could write this simply like this. If is face up, then we could do it this way first. Then we want to make it face down, right? Then is face up is equal to false. We could do that, right? And if not is face up, else we could write it something silly like this. Is face up is equal to true. We could do that. Hold on a second. I know you guys are thinking there's a better way. There is. And of course, what we want to do here is we also want to rotate. So we want to change the local rotation of my card, right? You know, from facing up to not facing up. That's what we want to do. So we're going to say something like, if it's face up, then our local rotation should be 0. So we're going to say that transform dot local rotation, right? And you can say that that is equal to not a quaternion identity, but a quaternion Euler angles, right? Or a quaternion Euler that is going to be, in terms of rotation, 0, 0, and is it the Z? It is the Z. And we're going to say that that is 0, 2, 0, 0, 0, right? So that's kind of like, we're going to reset everything to 0, 0, 0. However, what about if it is flipped, right? So this is face up. If it's not face up, then we're going to do a transform local rotation so that it is 180 degrees. Okay. And the other thing, this is where we would put the update function in. Okay, so if I wanted to put the update function in here, public, let's make it, sorry, void update. Let's put that update function back in, right? And we only put it in when we need it, right? If is face up is clicked, right? If it's checked, then we want to call the flip method if is face up changes. If is face up changes, if it's not what it was originally, right? Then we want to, you know, kind of flip it on the fly, which means if I check it, I want it to flip it. Does that make sense? So if I was to do that, then I would have to have a start function too, because the start function would start off with maybe a private member that is values that have changed. Like, for example, things like start facing. What's the start facing? Is it down or up? Let's do that. So private Boolean start facing, right? And then inside of our some kind of, we'll say void start, right? Or awake, it's up to you. Then you can say that start facing is equal to is face up, whatever that is. So if it was originally faced up, then start facing is going to check. And then you can check down here is if start facing is not equal to is face up, right? That means something has changed. Then we might want to choose, you know, flip. Now, the challenge here, right, is let's just uncomment these lines just for a second, or comment out these lines, right? So we start off is face up. We need to start off with something, right? So if we say that it's face up by default, because in our case it is, right? That's how our card starts off, by naturally being face up. We can say that is face up is equal to true. So it's checked. Okay, we set up at a specific point, right? And then what we can say is, well, if something changes, right, as an example, then we want to flip it. And what we also want to do is record the change. So we're going to say something like, well, now start facing is equal to is face up. Again, right? We want to do this every single time. Every single time we flip, we want to check, and this way we can check to see if it's changed. Okay, let me explain how all this works one step at a time and why would we do such a thing. Let's try it out and see what happens. So run it, and then we'll come back to optimize. All right, so here's our card, right? We're going to say that is face up is true by default. Let's run it, and let's see what happens. Here's our card. It falls down to the deck. You can see it's face up, but if I uncheck this, right, then it should be face down. And if I uncheck it again, then we're going to see it face up. How did I do that? Because of my checks, right? So it literally just flips it to whatever it's going to be. Now, be careful. It's also a 3D object. So when it flips, it actually does a couple things here, right? We could make it flip, like as in add some force or move it up, you know, whatever, and then flip it and let it fall again. That might be a really neat effect. Let's try that out. So again, going back to this, right? Let me explain how this funky code works, right? We're recording the initial facing, which is in this case up, right? And then what we're saying is if it's up, right? And if I check on it in the editor, that's what's happening here. If it's up and I'm checking in the editor ever, or if something changes, if I give it, if I change its facing through code, or if I change its facing in the editor, it's going to programmatically flip the card, right, in the scene. Why? Because it's always checking every frame if this is true. Are these two values different? Is the original way we had it set and the new way, is it changed, right? If it's changed, call the flip function, right? And then do this stuff, right? If it's not changed, ignore this, right? And keep going. Now, here's what we can do. Here's what we can do, right? We want to make it not only just so it's flipped, but also maybe so that it does something else. Like maybe it changes position. We take the card and we put it up at a certain spot. Like let's say, I don't know, up where it is on the game board. So if you look on the game board here, our card on the x-axis is you know, negative 0.82, whatever. Our y-axis so is like 7. Let's make it 10. So by default, all cards might start off, I don't know, this high, or maybe something smaller like 5, right? Well, 5 is too low because 5 is below the table, right? Our table is quite high, quite big, right? So there's my card. So that's why 7 worked. Let's make it so that it's 7.5. Oops, 7.5, right? Oh, that's the rotation. 7.5, right? So that gives us a value for our card. So our card is actually here on the table, 7.5 units above the table, or above the origin. All right, so that's where it is, 7.5 units above the origin. And then in our position, if we make this 0 for now, there's 0, 0. This 7.5 is what we want. We want whatever the transform is right now, the position on the X and the Z, whatever that is, keep it the same, but we want to put it back up to 7.5 as a default starting position. And that means that if we go back here, we can say something like, well, our transform, whenever we do any of this stuff, we want to do that. We want to set the, if we're flipping, let's change the transform dot position to a new vector3 object. What we're taking in the transform dot position dot x, and we're going to put it 7.5 units on the y, and we're going to pass through our transform dot position dot z. Okay. So what this does is it just moves it up, but doesn't change the X and Z at all. It just passes it through, okay? And then we're going to do this. Now, it's giving us this little underline here in ReSharper, and it's basically saying, hey, don't you want to convert this expression to a ternary operator? Guys, whenever we have one thing and we have an if-else, this is bad code, we can change it. So let's convert it to now a ternary operator. And if we were to do that, sorry, if we convert it, then it looks like this. It's a one-liner. Let me explain how this works for those people who are not familiar with ternary operator. And this is the condition we're testing, is face up. We can actually put this in brackets to make it cleaner looking, okay? This is kind of a condition, is face up. If it's true, then return everything after the question mark. If it's false, then return everything after the colon. So This is kind of like doing an if else in one line, and it's way more efficient. It's better. The compiler likes it more. It's the ternary operator. That's what this is. It's called ternary operator, ternary operator. The ternary operator allows us to do something that's more compiler efficient for us. And it's a one-liner. It takes up less code, and it's more readable, right, in many ways, all right? So I'm just going to put it like this. We change our position and our local rotation, right? And we're using the ternary operator to flip us around, right, and all that kind of stuff. And here also, there's another way to do this. It says, hey, invert the if. And it kind of looks something like that looks like this. If start facing is equal to is face up, then return. Otherwise, do this. And yes, that might be good if that's the only thing we're checking in update, but that's not the only thing we're checking. So I'm going to deny that suggestion. I'm going to say, no, I like it this way because I want it to skip all this and then do nothing in the update function. Okay, so that's what these are. All right, so this is pretty good. Let's see how it works now when we do it this way. So going back to this, and if I press play, then if I check it, it's going to do this. It's going to kind of make it rise up and change position every single time, which kind of is a little effect. It kind of looks okay. And it doesn't matter where we have the card. If I put the card, if I move the card in space, like over here, right, as an example, and I do the same thing in the game, right? So I just flip the card over. You can see it's just going to do the exact same thing. It's going to pass through the X and Z values, and it's going to fall to the table again because of our rigid body that we have installed. Okay, something that looks like this. Cool. What are your thoughts? That's kind of our first part. We added a card class, to the scene. Here's our trouble now. This is what we need to do. We need to add this card class to everything. Okay, that's what we want to do. But maybe there's a way, right, of automagically getting the suit and automagically, and I say that way, getting the rank name, right, from the name of the card that I'm putting this thing on. So I don't have to manually go on every single card. I don't have to manually assign any of that stuff. I can just attach the script to a card that's named properly, and then it's going to automatically set up those values, right? The value may be weird, right? As an example, might be weird, but at least I can go in and get those values, all right? Let's see if we can do this, okay? So do you understand what I'm saying? I'm saying this is called spade A, right? And if they're all named like that, and if I go to spades, they're all named the exact same way, spade 2, 3, 4, 5, 6, 7, 8, 9, 10, right? The rank name is called 10. I want to convert it, right, to whatever it is, right? And then the value is here as well, right, in some ways. Okay. Is the ternary better than that? I gotta be honest. Convert to int32 is face up times 180. Because face up's going to give you a positive or negative number, 0 or 1. And if it's 0, then it's going to multiply by 180. And if not, no, I think that's actually better. I'm being honest, right? Because it's a Boolean and you're multiplying. Multiplying is more, well, actually, I'm not sure in terms of, we'd have to test it and we have to do the timing function. You'd have to time it and see if mine is better than yours. And we'll talk about timing functions later. But the reason why I'm saying that is because it's one expression that you're using and I'm branching. And branching is typically worse than a timing function, like something that you're doing, right? Because branching is like, I got two universes I'm creating. Did I go to the coffee shop or did I stay home? Two universes, right? And the go to the coffee shop universe, I got in my car and I drove over to the coffee shop. And my stay at home universe, I didn't go anywhere, right? And maybe when I went to the coffee shop, I got struck by lightning, right? In that universe, I'm not alive, and in stay at home universe, I'm dead, or the other way around. Stayed home, place burned, right? I don't know. Went to the coffee shop, I didn't die. Why I'm mentioning this is to get you to remember branching, when you create an if statement, you're creating a branch, two different things that are happening, right? Two possibilities, right? Or three, depending on how you want to go, how many branches you create. So branching is typically bad, right? Yeah, right? Isn't that what it does? It's exactly what happens, right? So if you think about this, that's exactly what it does. It kind of creates two little possibilities, right? And then you follow that line of logic. It's two logic universes, call it whatever you like, right? But that's what it kind of does. It branches, and then it creates these two things. So branching is very bad in OpenGL. If you're doing any kind of graphics programming, branching, you don't want to ever do branching inside of a shader, okay? Because that just is programmatically just insane to do, right? So multiplying, anything what you're doing, multiplying is kind of an expression. An expression always trumps any kind of branching, right? So that's definitely better than what I did. Okay, now in this case, all right, if I had something else, if it wasn't just an if else, and it wasn't just a straight multiplication like that, like something that was just one value or another, and if it was something else, then ternary operator is better than if statements. Okay, so I think the way it would be is expression first, your way, then ternary operator, then if statements would be the way to go. And even better than if statements is switch cases. Switch cases is even better. It is a function call, that is true, but and so it is going on the stack. But the thing is, the multiplication, if you just multiply it, that'd be pretty awesome. And in C++ you could, because it's just 0, right? 0 or 1. But yeah, you're probably right about that. If you're converting first, not thinking about it again, if you're converting first, you are calling a function, and that function is going to be put on the call stack, and then it's going to come back. No, I think my way's faster in this case. No, I wouldn't do that. But maybe we'll find a different way of doing it in a second. Let's continue with this, and we'll take a short break soon. Okay, because I know I'm getting tired of talking. You're probably getting tired of hearing me, so we can probably take a break. So this is good. We've kind of improved stuff, and you know we have a recommendation from Justin to do something else, but what this does is just flips everything over, and that's pretty good. We can take it further, right? On start, when I have a card name, that when I attach this script, on start, I want the rank name to be decided by the name of the card, the rank name, or the suit name by the rank of the card. Because remember, the suit name is the first thing that we see: spade, heart, diamond, club, right? So this is pretty good. I like that, right? So that means that it's named properly for us. Now we can rename these things if we want to make it even better, okay? So one thing is these are all prefabs, and we have control of all of our naming conventions, right? So if we have a card, we could say something like spade 2, right? You know, or we can say 2 of spades, and then the value at the end. We could put it all in the name, and what would happen is when we're using that card, it would automatically set up these things here. Alternatively, we can just go through each one of these things and put it the rank, the suit, and the value. You know, but how would you get it from the name? Well, the name is a string, and the first part of the name, delimited by an underscore, is the suit. Let's see if we can do that. So if I took the suit name, if I took the name of the object, and I want to use string manipulation now to do this, if I said rank name is equal to the name of my object, the game object name, but I want to do a substring, right, from the start index, right, until now. There's a couple things. I want to find it says the length, whatever I want, but I want to be able to find something. So I want to take my name and I want to find something. You know, I want to kind of filter or find, and it says it's almost like I want to search, or it contains someplace that I want to look for. So it says first or default. That's what it does. So it says to source, but I want to find the name of my, or the underscore in my string. So how do I find the underscore? What's a way of doing that? Let's think about another way. In JavaScript, we have a split function. And so we have that here too. And it says, so here's our split function. It says, there's the separator, right? the character, we're going to use an underscore. And we're going to create that's the split, that's the substring, right? And it's going to return, so the split is going to return a string array. That's what it returns, a string array. And I care about the first string. Okay, that's what I want. So name split is what I want. And I want to return the first part, the first array to this thing is going to be the rank name. Okay, so the suit name. Okay. So split, if you hover over it, it says the split method, right? I'm just hovering over it to get this, returns an array of strings. We just talked about arrays today, an array of strings. And I want the 0th array, the 0th string, the first one that's in the thing. So that means the first part, if I take this thing and I split it by underscore, it means the first part is what I want to use to denote the suit. Okay. So if I do this and if I press save and if I kind of continue, and if I run it, then you should see as soon as I run it, suit should be pop up as spade. See that? Instantly, we know it's a spade. Why is this good? I can attach a script to any of these cards and instantly it's going to know that it's a spade. It's important. Okay. Next. A, which is the ace. This is the rank name, right? And now this is a little bit more complex because we have 2, 3, 4, 5, 6, 7, 8, and then A, Jack, King, Queen. It'd be nice if these things, Ace, Jack, King, Queen, were full names. Ace, Jack, King, Queen. We're going to use a switch case for this. Okay. So we're going to say that. Let's also split the name. Now, if we think about the name split, right, we can do it in 2 steps. We can do the name split again. So I can say something like, I want to do a switch case where I put the name dot split in here, and I want to split across the underscore, and I want the second one, which is the name of this thing, and then case, if it is an A, right, then this means we're going to return our rank name is going to be ace, right? And then we can do this. And then case, if it's a J, then we're going to say our rank name is equal to Jack. And you can see where I'm going with this. Then our rank name is going to be Queen. And case, if it's K, then our rank name is going to be King. We can do that. And then we have our default case, defaults. What do we do? I want to take that and I want to convert the number into a string. Huh. How do I convert a number into its string representation, right? Because that's what I would want to do, right? So why is this giving me a bit of an error? So name splits, curly brace here, curly brace here, name splits, open bracket, close bracket, open bracket, close bracket. This is 1. Switch case on, let's say name. Is it giving me this funny thing? I got a curly brace right here. That's weird. That's a empty switch case block. Did I mess something up? That's a Visual Studio thing. I'm pretty sure. You don't need anything like that. I don't think it'll give me an error here. Let me see. It'll tell me the error right away. Yeah, didn't error out. So if I press play now, it should give me if it's an A, it'll be an ace. Let's see if this works. Okay, so run it. And look, ace of spades, right? We don't have the value for an ace of spades right now. But if we're going to go do this, then, well, we can kind of do the same thing. We can say, well, the value is something we can also set, right? We can say the value is equal to 14 or 1 or whatever it's going to be, right? And, we can go through that and do all that stuff, right? And Jack would be, 11 and so on, right? We can do that. We could say that the value is 11, and we can also say that the value is 12 and 13, right? And the value is 13. We can say that. So these are all the values. What about for my other stuff? Like for the default cases, we could say that for the default case, whatever the number is in this other thing, we want to convert it into a value, and we want to convert it into the rank name. So the rank name is the is equal to the thing we just got, right? This thing, right? And so whatever this thing is we got it, right? And then, and this is, we don't have a thing for that. Let's just put name for now, right? And then the value will whatever that thing would be, converted to an integer. So int conversion of whatever the name is, right? And hear me out. And this is kind of what we want to do. This is, I'm just pseudocoding it with you for a second, okay? Can't do this. And we can't do this for a couple of reasons. One thing is we're polling the split function twice, which we don't want to do. Again, we're talking about the way we do it. There's two parts to the name, right? So we'll say that kind of the, it's almost like a string array is what we're making. And it's kind of like the name string. And it's name strings, or we want to call it, and this is kind of like the rank and suit and value is what we're going to try and get out of it. So it's almost like rank suit or suit and rank strings, right? So we can say var suit rank strings, that's equal to this part, this name split stuff, right? So we can kind of go this direction, right? So the var is it's like auto in C++, which basically automatically kind of figures out what the type is going to be. It's not like JavaScript, which is bad. It's implicit typing. It kind of figures out what the type is going to be. But then what it also does is it makes it strict typing. So it doesn't allow you to change it after you set it. Okay. So this basically says split it into two strings, the first part and the second part. The first part is the suit, the second part is the rank. So absolutely fine. Var is totally fine. And actually the compiler recommends it, believe it or not, right? So here the suit then always is the suit rank string, the suit rank string 0, right? That is what we did there, right? Suit rank string 0. And then and this one could be suit rank string 1, suit rank string 1, right? So that is, the way it is. So it's pretty good this way. And the reason why you want to do this as opposed to what I did before is because down here, we couldn't do anything. We lost whatever this is. I don't want to recalculate that again, right? That doesn't make sense. I want to only calculate this once right up here, right? So down here, then I can say that by default, the suit rank string is going to be the rank name. So the rank name is going to be equal to the suit rank string. And that's going to be, now, it's going to be 1, but it's a value 10. And I want to convert this thing to an integer, right? Because the rank name, well, actually, no, that's okay. Sorry. So the suit name is going to be suit rank string 0. So we can kind of put it in order, just like we have here. So we can say suit is this, right? Suit rank string 1 is the rank name. Rank name would be like the ace or whatever it's going to be, right? And then we want to convert for these ones, for every other thing, for like 2, 3, 4, 5, 6, 7, all the way up to 11, to 10. We want to convert them into an integer. So I want to do a string integer conversion. And for that, if you look it up, if you go string to int C#, then you're going to see that I want to convert a string to a number. How do I do this? Again, Microsoft, to do it, you want to try parse is what you want to do. So int32 try parse to whatever you want it to be. So let's try that. So we're going to say int32 dot try parse, and I want to try parse my string, which is going to be the rank name, this one. Actually, we just say rank name. Whatever the rank name is, I want to try parse it. Now, why is this not working? And it says, cannot resolve method try parse. Candidates are try parse string, and then afterwards, it's the name and the integer that's going to come out, right? And so what we want to do is we want to put in here the value that we're going to use. Value is what we want. And the value is the object. Now it says cannot resolve. We need it to be an out, right? We're giving it an integer, but we want it to be an out int. Out means a reference. Okay, that's what we want. And sometimes it'll give us a reference like that to fix it. So we need to put the out keyword in there. Out means I want to dump my value, whatever I'm trying to try parse, out into the value object, which is up here. Okay, so this is going to do the conversion for me. So this line, convert to an integer. That's what this is going to do. And let's see if it works. So let's try this. So run it back to Unity. It's not perfect. Well, let's talk about it a little bit. Unity's taking its time. There we go. And if I run it now, we should see that the spade A, right, has ace of spade, and value, right? Value is 1, right? We gave it a value of 1. We can give it a value of whatever we want. And what if I bring in another thing? What if I just grab the 2 of spades and bring that in? And let's put the 2 of spades up with everything else. So let's say 7.5 above the table. We'll move it next to the ace of spades like this. And then in the 2 of spades, we're going to attach that same script. This is the beautiful thing about this. So I take the script, attach it without doing anything else. And let's see what happens. If I press play, we should see them both fall to the table. And we can see that the 2 automatically knows that the rank name is a 2 and the suit is a spade and the value is a 2. And if I flip it, it's going to do the same flipping action that we did with the ace. All right. So that's kind of neat the way that works, right? Calculates what it is. All right. And it does it for all cards. If I take that same script and attach it to all my cards now, it's good to go. Okay. Questions around this? Yeah.
Yeah, I've encountered an issue. It tells me the name int32 does not exist in the current context.
So the reason why is because up here, right, make sure you have system. It's also included your system.
Yeah, there you go. I forgot to, I must have missed that step. Thank you.
No, I didn't do it. It automatically did it for me because I'm using ReSharper. ReSharper fixes the problem, right, for me automatically.
Yeah, let's see.
All right, so that's what this does in 32. What about if it wasn't in 32? What if I said something else like in 16? Can I do it the same way? It does also in 16. In 16 is oops, let's try that again. Int 16, this one. And then if we tried to do that, it would say built-in ref type references inconsistent with code style. Right? So it doesn't like that. It likes in 32. I'm okay with that. All right, so that's what this does. Why? Because this is an int32 by default. See, int is an int32, and that's why this has to be an int32, right? If I made this an int16, which is a short int, as opposed to a long int, which is what this is in other languages, then it would convert, okay, the same way. So this is the conversion script. but we have a problem. And the problem is our naming sucks, right? We want to make some kind of two-string method here to change this. So let's do a two-string method, public, and it's going to return a string. We're going to call it toString. And the toString method is an overloaded method. So the keyword new is required toString because it hides method string unity toString. It says method toString is never used. Okay, so that's what it does. But here, what I want to do instead of what they're saying is I want to return. And if I return, I can return whatever I want. It overloads or overrides my my method. All right, so that's what it does. This is method overriding, right? Or it's overloading is where I have more than one toString method. That is the way it is. So if I said something like, if I put the override keyword in there, right, override, then it says you probably don't need it. That's what it says. It says that sort modifiers, right? It says it wants to do it this way. All right, so this is the right way to do it, a public override toString method that overrides the built-in toString method of this thing, right? You need to put the override in there because what it's going to do is it's going to return whatever we want to put out there. So this is what it's going to say. So we're going to return now the rank name of, and then the suit name, right? So it's going to be, and we can do interpolation. So we can do interpolation here, right? And for C#, let's look at interpolation because I can do it, but then you're not going to know. Go back out here. If I do string interpolation, and if I said C#, right? C#'s the latest version of string interpolation in C# allows you to do this thing, curly braces, right? And like this, okay, curly braces allow you to do that. So if I write that down, if I go in here and go curly braces, and in the curly braces, I put in a value that's recognizable, like for example, rank name. So if I go rank name, then suddenly the curly braces, turn out like this, and then you need a $sign in front. Now that's my resharper recoding for me, but that's what you would need. So rank name followed by of, and then the suit name, suit, right? S, because we don't have the S. Ace of spades, right? That's what that is. And what we can say is, when this thing enters the world, let's do a little bit of debugging, and then let's print that out. So we can do a debug.log, where we can put out the message, which is whatever this is, toString. So I want to do this. And you're going to be like, why this? Because this is a card, and this will automatically, kind of use the toString method to output. And let me try and do this and see what happens, and then see if I'm crazy. All right. Let's go back to this. When C# decides to do whatever, and if I press play, we should see in the console two things, right? Ace of spades and two of spades. How did I get that? Because I passed in the value this to debug log. By the way, what's another way to debug log in Unity? Do you guys know? So there's debug log. What if I did, is there a print? Can I do that? And if I did print, can I print the name, which is this? Can I do that? And what does print do compared to debug log, right? So let's take a look at the difference between debug log and print. So back to this, and if I press play, you're going to see that it's identical. So whatever you want to use, debug log or print, is no problem. Some people use print because it's just very simple, right? So I'm doing this because then in our toString method, if we want to use it later, I can identify the object by saying the ace of spades. Here's what I don't like. And I want to leave you with this before you and we go on a short break, because we're going to take a short break now and come back and finish this in class exercise, right? I don't like the 2. I want it to be words. I want to convert the number into words in C#. Is there a way to do that? Because here I've done this conversion. I mean, I can simply go down and do like 2, 3, 4, 5, 6 all the way down, switch case, which is like an if else, right? If else, if else, if. Is there another way? Can I convert my number? Can I convert my number to some kind of, name, friendly name? And here's some hints that I want you to take away from this. What about searching it up? Let's see what it tells us. So convert number to string, but I want to make it to a string number, a string word in C#. Can I do that? So I want to convert, right? And because convert numbers to words in C#. So they've got a little thing here, and they've got this massive, little thing to convert it. Do I want to convert it like this? Look at, so here's my 0, and I want to convert it into, I want to go from 1 to something else, and I want to convert the number into this. You could certainly do this, a nice idea, right? So I can have a string array, right? And the string array would be, 0, 1, 2, 3, whatever. And I take that, I can take the element of the string array and come back out and give me a number, right? Let me explain. So what if I did something like this? What if I said, I call it string numbers. So I want to make a variable called string numbers, right? And the string numbers is going to be an array, right? That's what I want. So I want a new array, right? And the array I'm going to initialize, right? We just talked about this, is 0, 0, and then ace 2, 3, 4, 5, 6, 7, 8, 9, and 10. What if I do this? Again, hints on how to do the same thing, right? So I remember this is initialization syntax. We just learned this in the PowerPoint slides, right? And I added 0 and ace there because we don't really care about them, right? And I said, as we loop through, if I was going to take the strings, this is noticed by hover over var string numbers is now an array of strings. That's what it is. So I don't have to do array of strings. It kind of figures out what this thing is by me doing the var keyword, right? An array of strings. If it's an array of strings, and if I convert the value, right, whatever the value is, right, I want to convert the value, which is the rank name. The rank name is the number that I'm converting, which is this. And instead of doing the rank name, what if I took this part and put it here? So we do it a little bit differently, right? So I want to get the value is where it's going to come out, but instead of the rank name, we put the suit strings here. We can do that, right? And we do the rank name after, or we say something like rank name. Well, that's equal to the, string numbers and value. What if we did that? And what that will do is make our names look really nice when we print them out, and it'll change our rank name so it's way nicer than what it was before. Let's see how that works, and let's see if you understand what I'm saying. Okay. So back to this. if I press play now, and here's my rank name, 2 becomes the name. So even though it says 2 up here, I converted 2 to 2, and now it says 2 of spades. Look how beautiful that is, ace of spades, right? So that is way nicer than 2, the number 2 of spades. I like it this much. This is kind of the way we would talk if we were saying it in this, just writing it, 2 of spades, right? And how we got that was, this is kind of the funky way we did this. We said, let's make an array of number words, right? 0, ace, 2, whatever, right? Maybe that's what this should be called. We'll call them number words. So we can refactor, rename here, and we'll call this number words, right? And number words 0, right, would be 0. Number words 1 would be ace. Number words 2 would be 2, and so on. Okay. So that's kind of a way of doing it. And ace, jack, queen, we can't do much there because those are, we don't have a conversion for those. Ace, jack, queen, king, right? We don't have that, but we could put that here too, could we not? Could do that, right? Could say that, you know, the value is like 11, 12, blah, 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 blah. We can put that in there. Ace, jack, queen, king, which is something less to think about here, right? Let's see if we did that. If we said something like, okay, let's keep going. So jack, queen, king. What if we did this, right? So we kind of made an array that held these words, right? And then instead of our rank name, we can just convert the rank name from the number of words. And that means I can just do this because we're doing it all the time. We don't have to do that here. We can do that here, couldn't we? Because we don't have to do a switch case. We just have to pass in the value, whatever this value that we gave it, and it'll come back with whatever the word is going to be specifically. So I don't have to do this anymore because we've already done it. And let's test it. Still the same. Still the same. Right. Optimizations is what we're talking about here, where we're trying to figure out ways of doing this all the time. Now, it'd be lovely if we had a chance to not even do this at all, and we literally could figure out the ace as what it is, and so on. So the ace has a value of 1, we know that, but it's kind of like together, right? Ace is the thing, jack, queen, and king. We'd have to reorganize our names though for this because there is no easy way to get that. But we do have a way of parsing things to automatically get everything. And this part, although all of this is in start, it shouldn't be, in my opinion. This should all be in its own method, because here's something I want to tell you that I want you to think about when you're coding from now on with me, which is every method should have one job, right? Start has initialization. And this stuff that we're doing here is not initialization. This thing we're doing is we are basically defining the properties. We're kind of like, you know, building out, you know, we're going to build our card. That's what we're doing. And so that's what I want to do here. I want to, for the stuff that's building up the card and all that stuff, we could also call this initialize card. That's another way to think about this. I want to take all of this stuff, even down here with the face up and all this kind of stuff. I want all this stuff here, and I want to initialize my card. I want to pull this into another function. So the way to do that, you can certainly make a function and copy paste, or you can take all of this, right click, and I'm going to go to refactor, extract method, and then it's going to go to extract method. Now this is ReSharper doing my work for me, right? So one way you could have done this is make a new method name and then take all this stuff, cut, paste inside the method. And that's another way to do it. But here, the refactoring works nicely, where I can say something like, let's refactor this and call it something like initialize. right? And the initialize function, what it'll do is it will just look like this, initialize, right? Wow, I wonder what that is. That's weird. And then it does all of this, right? So it kind of brings all this in here and it kind of abstracts it away. And a really good reason for this is then you can collapse this whole thing down, right? I can collapse this whole block, right? I couldn't collapse stuff in here, but here I can collapse it in Visual Studio. I don't have to see it all if I don't want to. If I'm already done with this function, I can collapse it down to make it easier for us to work with, okay? So that's what this does. And this initialize method, what it's doing for us is it's helping us, kind of figure out, what the card is called. Last part before we go on break, last part, okay? Now that we have all of this, now I'm comfortable with attaching the card class to all the cards all at once, okay? And the way this can be done is, let's just delete these cards here. This is just a test that we had this. That's why we brought these two different cards in here. Let's delete them. So delete. And what I want to do is I want to go into clubs, all the club cards here. This is inside of resources, prefabs, cards. Select everything. And then go back into my scripts folder and drag and drop that card script on top of it like this. Boop. Let me make a noise for you. Boop. And I want to do the same thing, the same. Right now, here's something else you can do. I can certainly go through them and go through each one of these cards separately. Or on the top here, where it says favorites, I can look at all prefabs. I can look at all prefabs and do the same thing with the prefabs. I can kind of look there and I can see them as a list. These are all the ones I just changed, but these are all the prefabs. And the one I can actually look through all of these all at once, all the prefabs here. So I can look at all the ones that I want. I can highlight the ones I want to change here by having this little filter, right? And then I can just, going back to the scripts, I can just drag and drop it onto my filter. Right now, the problem with this is when the filter itself, it doesn't lock what I'm looking at. So when I look away, then it's gone, right? Unless I click this little lock button. If I lock this little lock button up here, if I lock it, maybe if I go to the script here, then maybe it will look at it, but it doesn't. So that's what I'd like to do, but clubs all got changed. Look, clubs, they all have the script. Right, what about diamonds? Let's just do it one at a time. I'm trying to be fancy and it's not working. So I select all the diamonds and I'm going to go here and just drag and drop that one. Okay. I'm going to select all the hearts and I'm going to drag and drop the script in here as well. And I go into spades, select all the spades, and then drag and drop that script into there as well. Guess there's it. So I've got all of them have that same script. Okay. And why is this good, right? I did it to the prefab. I didn't do it to objects in the scene. And that means when I pull the card in, I didn't do it to the joker. We're not going to use jokers in this simulation and stuff. But if I bring in any of these things in, let's say, for example, I bring in the ace of clubs in here. And by default, notice that the position is 0. That's another thing we could possibly change, right? We want the position to be 7.5 starting off. We could, instead of it starting like under the table here, which is kind of not what we want to do, we can make that change happen now too. Might as well. So again, I'll kind of select all these ones and then change the starting position to 7.5. Okay. And the same thing goes with diamonds. I can take all the diamonds and set the starting position to 7.5. And then select all the hearts and then select all these and make this 7.5. And last one is the spades. Change all these spades and change the Y position to 7.5. And now if I bring a card in, so again, let's go back to clubs and I bring an ace of clubs in, you can see it comes into the scene nicely. I can pull it across. And let's say I want to grab the ace of diamonds and bring that in. And you can see that that is nicely what it is. And I can go to the ace of hearts and bring that in, right? And you can see that's pretty good. put that in the middle. And finally, the ace of spades, bring that in, and then just drag it to the other side. And there we go. And if I run everything now, what you should see is it drops down into this thing, and each one, ace of clubs, right? Ace of diamonds, ace of hearts, ace of spades, they all say the right things, which is pretty good. And I can flip any one of them as I like when we play our game. All right. So kind of a really good value that we have to our stuff. Now we have the printing out here. We don't need that. I have that in the script. Let's just go back down here. I just use that for, just to print out this thing. So we're just going to get rid of this. Right. And this is pretty good. Save. And before we go, right, I want to ask you questions. How are you feeling about this stuff now? Is it becoming more comfortable for you, the stuff I'm doing? Is it something that you've done before? How are you feeling about it? Would you do it differently than me? Hopefully, right? What are your thoughts? Yes,
I think I'm still struggling a bit to understand it, but I think I could just like rewatch the video and stuff, and I should be able to understand eventually.
Let's focus on the thing that is confusing. Which part is which part do you not understand? That's the thing. Like tell me, and then I can probably maybe clear away some of the mud.
It's like it's hard to describe because it's like nothing specific there. It's just because I like missed like a few bits here and there because I was trying to like keep up with my typing and stuff. Yeah.
I'm sorry. I go fast. I apologize.
It's all good.
Yeah. All right. So okay, that's good then. So thank you for that.
Yeah.
No, so one last thing I want to do here is in the inside of my card, just to finish up my card class, I want to make a header. And the header is going to say something like card properties, right? And what card properties the header does, this is an annotation. That's what it's called, the header annotation. And this annotation, if I go back to the Unity game engine, let's go back to the Unity game engine, you're going to see that it adds this little header, card properties. So it's kind of nice, right? In terms of how it looks here, right? And each card now can be identified. That means when I deal the card, I have a value. And because I have a value, I can do a comparison. And if I can do a comparison, I can do a sort, I can do an insert, I can do a shuffle, I can do a hand calculation, a value for the hand. I can do whatever I want, right? And an example of this would be if I have three things that are the same. I want to do matching, right? Example, I have three aces, right? Well, there's a couple ways to check this. I could check the rank name, right? So ace, 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 I could check that. I could also check the value, so, 111, whatever it's going to be. Those are the two ways I can check. And if I can say that I have more than one ace, as an example, or more than one value of one, then I have a pair, or I have a three of a kind, or have whatever, right? That's one way of doing it. I can also use something like regular expressions now, where I can hunt for an expression. I can make an expression of what my hand is like, right? Where a hand might be another class that I create. And the hand includes, I don't know, some kind of a number of cards. And I can search through my hand. I can list all these things out. Ace, ace, ace. I only care about, for example, the ranks, 2, 2, 2, whatever, or spade, spade, spade. And I can check, kind of give myself some kind of, value to my hand. For example, two pairs might be better than ace, king, a three of a kind might be better than, a pair, right? And maybe two pairs, actually, if I'm not wrong. And so on. And four of a kind, trumps a lot of the other ones. And, a straight, what does that look like? And so on. You can make these rules for the game now. You can start creating your mechanics for the game compared to what we had before. Remember, the games they always got like mechanics dynamics, and some kind of aesthetic, right? And the mechanics of the game is what we're kind of building up. We're building up our building blocks of how this game is going to work, right? The simulation. All right, let's save this thing for now. And when we come back, we've done a lot of work. I could have done a bunch of commits here. I didn't do that. And I want to talk about how to create a brand new, we can add this into our in-class exercise, folder later. Let's take a short break. Let's take we've gone long. Let's take 10 minutes. And when we come back, we'll be about 11:40-ish, right? We'll come back and then we'll continue with putting this simulation, kind of up on GitHub and putting the simulation, producing the simulation as a WebGL game, okay? I want to do those things. And that's kind of what your in-class exercise is going to be, finishing the cards, attaching the script to the cards. You'll see that when I make my little lab report for you guys later today, then it's going to have all that detail. Do this, do this. These are the tasks. And then all I'm doing is I'm helping you along for your assignment number 1. Okay, let's take a short break and we'll come back in around 10 minutes. Okay.